A pleasant day, grade 9 Socrates. Today, we'll be discussing the first lesson of our subject, Mathematics 9. But before we move on, I want you to give this quotation from Paul Halbos. And he stated that the only way to learn mathematics is to do mathematics. So you cannot learn mathematics, you are not going to do it. So as a sort of advice, before we move on, I want you to get your lecture notebook and your pen and get ready to jot down and do the examples in our discussion. So for today's lesson, we'll be dealing with quadratic equations. So the first one is solving quadratic equations by the square root property. So this is the first step in solving quadratic equation. So we previously have used factoring to solve quadratic equations. Remember, when you were in grade 8, we already discussed how to solve equations by factoring. And this chapter will introduce additional methods for solving quadratic equations. Square root property. If b is a real number and a squared equals b, then a is equal to plus or minus square root of b. Like for example, if we have the equation x squared equals 49, how can we find the value of x? So since this is a quadratic equation, we are expecting to have two values of x. So x now is equal to the square plus or minus the square root of 49, which is equal to plus or minus 7. So the value of x are positive 7 and negative 7. Solve 2x squared equals 4. In this case, the value of a is not equal to 1. The value of a is equal to 2. So the first step that we have to do here is to eliminate the numerical coefficient of x squared by dividing the whole equation by 2. So we will be having x squared equals 2. And then we square both sides of the equation. Square root of x squared is equal to x, and the square root of 2 is equal to plus or minus the square root of 2, since 2 is not a perfect square. How about this quadratic equation? The quantity of y minus 3 squared equals 4. So what we are going to do is to square both sides of the equation. So we will be having y minus 3 equals plus or minus the square root of 4. And the square root of 4 is 2. So y minus 3 is equal to plus or minus 2. And then simplifying it further, we have 3 plus 2 equals 5. Then 3 minus 2 equals 1. So the values of y in this quadratic equation are 1 and 5. Another example, suppose that we have x squared plus 4 equals 0. We can also solve this quadratic equation by extracting the square root or the square root property. So we transpose positive 4 from the left side of the equation to the right side, or we apply the addition property. We add negative 4 to the left side and the right side of the equation. So you will be having x squared equals negative 4. By extracting the square root, we'll be having x squared, the square root of x squared equals the square root of negative 4. So x is equal to the square root of negative 4. So in this case, we may say that there is no real solution because the square root of negative 4 is not a real number. Another example, the quantity of x plus 2 squared equals 25. So we extract the square. So we'll be having x plus 2 equals the square root of 25, which is plus or minus 5. And then we simplify it by transposing positive 2 from left to right, or by using the addition property of equation. We add negative 2 from to the left and right side of the equation. So we'll be having x equals negative 2 plus or minus 5. So x now equals negative 2 plus 5, or x equals negative 2 minus 5. So the value of x are 3 or negative 7. Another example. The quantity of 3x minus 17 squared equals 28. So we extract the squares. So you'll have 3x minus 17 equals plus or minus the square root of 28. Take note that 28 is not a perfect square, but we have a perfect square factor in 28, and that is 4 times 7. So 4 times 7 is 28, and take note that 4 is a perfect square, so we can get the square root of 4, which is 2. And then square root of 7, since 7 is not a perfect square. So 3x now equals 17 plus or minus 2 the square root of 7. And then we eliminate the numerical coefficient of x by dividing the whole equation, or both sides of the equation, by 3. So x now equals 17 plus or minus 2 the square root of 7 all over 3. So these are the values of x in the quadratic equation. The first one is 17 plus 2 the square root of 7 all over 3. And the other one is 17 minus 2 the square root of 7 all over 3. And that is how we solve quadratic equations, by extracting the square root or using the square root property. Let us have the second one. Solving quadratic equations by completing the square. In all 4 of the previous examples, the constant in the square on the right side is half the coefficient of the x term on the left. Also, the constant on the left is the square of the constant on the right. So, to find the constant term of a perfect square trinomial, we need to take the square of half the coefficient of the x term in the trinomial, as long as the coefficient of the x squared term is 1, as in our previous examples. So, let's do completing the square. Solving quadratic equations by completing the square. What constant term should be added to the following expressions to create a perfect square trinomial? So we have x squared minus 10x. What would be added to make it a perfect square trinomial? We add 5 squared or 25. So to make it a perfect square trinomial, x squared minus 10x plus 25. How about with x squared plus 16x? What are we going to add to make it a perfect square trinomial? So we add 8 squared or 64. How about here? X squared minus 7x. To make it a perfect square trinomial, we add 7 over 2 squared or 49 over 4. What have you noticed about this making it a perfect square trinomial? Take note that we add 5 squared or 25. In here, we add 8 squared or 64. Here, we add 7 over 2 squared or 49 over 4. Where do we get that? So 5 squared is 25. It is from 1/2 of 10 squared. What is 1/2 of 10? That is 5. And then you get the square of that, so you will be having 25. Here we get 1/2 of 16, that is 8, and then we square, that is 64. Then we get 1/2 of 7 over 2, we get 1/2 of 7, and that is 7 over 2. So we get the square, so you'll have 49 over 4. That is how to make a perfect square trinomial out of the expression with x squared and x terms. We now look at a method for solving quadratics that involves a technique called completing the square. It involves creating a trinomial that is a perfect square, setting the factor trinomial equal to a constant, then using the square root property from the previous section. Okay. Solving a quadratic equation by completing a square, this is the first step. If the coefficient of x squared is not 1, divide both sides of the equation by the coefficient. So it's very important that we set the coefficient of the x squared term or any variable in the second power equal to 1. If not, you are going to divide the whole equation or both sides of the equation by the numerical coefficient. For example, if you have 3b squared, then divide the whole equation by 3. If you have 10m squared, to make the numerical coefficient of m squared equal to 1, then divide the whole equation by 10. Number 2. Isolate all variable terms on one side of the equation. So all variable terms, all the terms with unknown variables, with x, with m, with t, with r, any variable, you isolate all of them at one side of the equation. You may isolate them at the left or at the right, but to make it easier, I suggest you to isolate all those variable terms at the left side of the equation. Complete the square by getting half of the coefficient of the x term, or any variable with the power of 1, added to both sides of, and then square, then add to both sides of the equation. For example, we have the term 5 or 50. For example, we have 10m. What is 1/2 of 10? 5. And then you get the square of 5. So you will have 25. And then you add 25 to the left and to the right of the equation. And then factor the resulting trinomial. And then use the square root property. We'll be going back to the first way of solving the quadratic equation, which is extracting the square or the square root property. Let us have an example. Solve by completing the square. We have y squared plus 6y equals -8. In this case, we already have a square term with a numerical coefficient of 1, so we don't have any problem with that. And then the variable terms are already isolated at the left side of the equation, equals -8. So -8 is in the right side because it's constant, not a variable term. So to complete the square, we have to get 1/2 of 6. What is 1/2 of 6? That is 3, and then you get the square of 3, that is 9. And that is what we are going to add to the both sides of the equation. Plus 9 here and plus 9 at the right. And then the next step is to factor the trinomial here, y squared plus 6y plus 9. We factor it out. So we will be having y plus 3. The quantity of y plus 3 squared equals 1, since -8 plus 9 equals 1. And then we go back to the square root property, the first method of solving quadratic equation. We extract the squares to the both sides of the equation. So you will have y plus 3 equals the square root of 1, which is plus or minus 1. And then by addition property of equation, to eliminate this 3, to remove positive 3 at the left side of the equation, we add negative 3 to left and right. Or we simply transpose positive 3 and positive 3 will become negative 3. So you will have y equals negative 3 plus or minus 1. And simplifying it further, y is equal to negative 3 plus 1 is negative 2. Negative 3 minus 1 is negative 4. And these are the values of y in the quadratic equation y squared plus 6y equals negative 8 by solving it through completing the square. Let us have another example. So we have here y squared plus y minus 7. Check the squared term. So the numerical coefficient is already 1, so we don't have any problem with that. But the constant term is in the left side of the equation. So what we are going to do is to move negative 7 from here to the right side. So we'll be having y squared plus y equals 7. And then we get 1/2 of the numerical coefficient of y term. So the numerical coefficient here is 1, and we get 1/2 of 1, so that is 1/2. And we get the square of that. 1/2 squared is equal to 1/4. So we add 1/4 to both sides of the equation here, and 1/4 here to the right side. And then simplifying it, we get the factor of y squared plus y plus 1/4. And that is equal to y plus 1/2. The quantity of y plus 1/2 squared is equal to 29 over 4. So we get the LCD here. Take note that 7 is a whole number, so the denominator is 1. So you will have 4 as our least common denominator. So 4 divided by 1 is equal to 4. And then 4 times 7 is 28 plus 1. So that is 29 over 4. So you already have the equation. And then we move back to the square root property. We extract the square to both sides of the equation. So you will be having y plus 1/2 is equal to plus or minus the square root of 29 over 4. And this is equal to plus or minus the square root of 29 over 2, since 4 is a perfect square and 29 is not. And then simplifying it further, you will have negative 1/2 plus or minus the square root of 29 over 2. And then we add the two fractions. So their denominators are already common, which is 2. So you will have negative 1 plus or minus the square root of 29 all over 2. Another example. So we have here 2x squared plus 14x minus 1 equals 0. So we have a numerical coefficient in the x squared term. So what we have to do is to eliminate that by dividing the whole equation by its numerical coefficient, which is 2. So dividing the whole equation by 2. So in this case, negative 1 is being transposed at the right side. So you have 2x squared plus 14x equals 1. And then divide the whole equation by 2. So you will have x squared. Since 2 divided by 2 is equal to 1. 14 divided by 2 is equal to 7, and then 1 divided by 2 is equal to 1/2. And then get the half of 7, so that is 7 over 2, and then get the square. 7 over 2 squared is equal to 49 over 4. So we add 49 over 4 to both sides of the equation. And then 1/2 plus 49 over 4 is equal to 51 over 4. So the LCD is 4. So you have 4 divided by 2 is equal to 2 times 1 is 2. 2 plus 49 is 51 over 4. And then we get the factor of the trinomial x squared plus 7x plus 49 over 4, and that is the quantity x plus 7 over 2 squared equals 51 over 4. And then we again move into, or we apply the square root property. So you will be having x plus 7 over 2 equals plus or minus the square root of 51 over 4. And take note that 4 is a perfect square, so we can eliminate the square root at the denominator. So you will have plus or minus the square root of 51 over 2. So the values of x are negative 7 over 2 plus or minus the square root of 51 over 2, and 2 being the denominators are already common to the two fractions. So we can add negative 7 and plus or minus the square root of 51 all over 2. So that is how we solve quadratic equations by completing the square. The last one, or the next one, is solving quadratic equations by the quadratic formula. So in here, we'll be using quadratic formula. We just need A, B, and C, because there are instances that completing the square and square property is not applicable in solving quadratic equations. That is why we need to use quadratic formula in those cases. So another technique for solving quadratic equation is to use the quadratic formula. And the formula is derived from completing the square of the general quadratic equation. A quadratic equation written in standard form, ax squared plus bx plus c equals 0 has the solutions. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is the quadratic formula being derived from the standard form equation of the quadratic. So, example, we solve 11n squared minus 9n equals 1. If we are going to apply the first two techniques in solving the quadratic equation, it will be a little bit harder. So, let's just use the quadratic formula. So, we transform the quadratic formula into the general form. So you will have 11n squared minus 9n minus 1 equals 0. So we equate the quadratic equation to 0. And then we identify A, B, and C. So A is the numerical coefficient of the squared term. And then B is the numerical coefficient of the n term. And C is the constant. So your A now is 11, B is equal to negative 9, and C is equal to negative 1. And then we substitute the values of A, B, and C to the quadratic formula. So you will have here negative B. So negative of negative 9 will become positive 9 plus or minus the square root of B squared. What is our B? That is negative 9, so you have negative 9 squared minus 4 constant into the formula 4 times AC, and our A is 11, our C is negative 1 all over 2A. So you have 2 times 11. Simplifying it further, you will have 9 plus or minus the square root of negative 9 squared is 81. Plus 44, because negative 4 times 11 is negative 44 times negative 1 is positive 44 all over 2 times 11, which is 22. Simplifying it further, you will have 9 plus or minus the square root of 125 all over 22. And then you will have 9 plus or minus 5 the square root of 5 all over 22. Since 125 is not a perfect square, but it has a perfect square factor, which is 25. Okay, let us have another example. when 8x squared plus x minus 5 halves equals 0. So in this case, the whole equation is already being equated to 0. So we just identify A, B, and C. Or to make it simple, we multiply both sides by 8 to eliminate the fraction. So upon multiplying this equation by 8, you will have x squared plus 8x minus 20. Since 5 times 8 is 40, divided by 2, which is 20, equals 0 times 8, 0. So identifying A, B, and C, A is, again, the numerical coefficient of x squared, which is 1. B is the numerical coefficient of the x term, which is 8. And C is the numerical coefficient, is the constant term, which is negative 20. And then, we substitute this into the quadratic formula. So you will have negative b, so negative 8 plus or minus the square root of b squared. So you have 8 squared minus 4 times a, 1 times c, negative 20, all over 2a. Simplifying it further, you'll have negative 8 plus or minus the square root of 8 squared, which is 64. The negative 4 times 1 is negative 4 times negative 20 is positive 80, all over 2. And then you will have negative 8 plus or minus 64 plus 80 is 144. So you will have the square root of 144 all over 2. And we know that 144 is a perfect square. And that is equal to 12. So you will have negative 8 plus or minus 12 all over 2. Simplifying it, you will have negative a minus 12 is negative 20 divided by 2 is equal to negative 10. And the other one is negative 8 plus 12 is equal to 4 divided by 2 is equal to 2. So the value of x are negative 10 or 2. Another example. X times the quantity x plus 6 equals negative 13. So this equation is in factored form. So we have to simplify it. We have to multiply x to the quantity x plus 6. So you will have x squared plus 6x. Since x times x is x squared, x times 6 is 6x by distributive property. And then, isolating all the terms at the left side of the equation by addition property, we add positive 30 to both sides of the equation. So you will have plus 30 here equals 0, since negative 30 plus 30 equals 0. So our quadratic equation now is x squared plus 6x plus 30 equals 0. And then identifying a, b, and c, you will have a equals 1, b is equal to 6, and c is equal to 30. And then substituting the values of a, b, and c to the quadratic formula, you will have x equals negative b, so you have negative 6, plus or minus the square root of b squared, so you will have 6 squared, minus 4 times a, which is 1, times c, which is 30, all over 2a, 2 times 1. And then we simplify it, so you will have negative 6 plus or minus the square root of 6 squared, which is 36, minus 4 times 1 is negative 4, times 30 is negative 120, all over 2. And then you will have negative 6 plus or minus the square root of negative 84 all over 2. So what have you noticed? You have a negative sign under the radical. So we may say that there is no real solution in this quadratic formula because we don't have square root of negative integer. Okay, so those are the three ways on how to solve for the quadratic equation. The first one is by applying the square root property. The second one is through the use of completing the square, and the last one is using the quadratic formula. This time, let's talk about the discriminant of the quadratic equation. The expression under the radical sign in the formula, b squared minus 4ac, is called the discriminant. The discriminant will take on a value that is positive, 0, or negative. And the value of the discriminant indicates two distinct real solutions, one real solution or no real solution respectively. Using or upon solving the discriminant of the quadratic equation, we can identify how many distinct solutions or real solutions does the quadratic equations have. Like for example, use the discriminant to determine the number and type of solutions for the following equation. We can identify the number of solutions and the type of solutions of the quadratic equation using or upon solving the discriminant. For example, we have 5 minus 4x plus 12x squared equals 0. We can identify how many solutions or what type of solutions does these quadratic equations have. A quadratic equation. So we identify A, B, and C. Our A is the numerical coefficient of x squared, which is 12. Our B is negative 4, and our C is equal to 5. Again, the formula in solving the discriminant is b squared minus 4ac. And then by substitution, we will have b squared. So you have negative 4 squared minus 4 times a, which is 12, times c, which is 5. Simplifying further, you will have negative 4 squared is 16. Then 4 times 12 times 5 is equal to negative 240. So you will have 16 minus 240. And then simplifying further, our discriminant is equal to negative 224. So there are no real roots. So if the discriminant is negative, if the discriminant is less than 0, then there are no real solutions. So always remember, if the value of the discriminant that you get is negative and less than 0 or less than 0, then there are no real solutions in the quadratic equation. Okay, steps in solving quadratic equation. So we move back to the discriminant. But if the value of the discriminant that you solve is equal to 0, then there is only one real solution in the quadratic equation. If the discriminant is positive or greater than 0, meaning if the discriminant that you get is 1, 2, 3, 1/2, any number which is positive and greater than 0, then there are two real solutions in the equation. So that is how we solve for the discriminant. Again, if the discriminant is equal to 0, there is only one real solution. If the discriminant is greater than 0 or positive, then there are two distinct real solutions. If the discriminant is less than 0 or negative, then there are no real solutions in the quadratic equation. Solving quadratic equations. Steps in solving quadratic equations. If the equation is in the form, the quantity ax plus b squared equals c, use the square root property to solve. This is summing up. If not solved in step 1, write the equation in standard form. Try to solve by factoring. If you haven't solved it yet, use the quadratic formula. So our last resort is the quadratic formula. Example, solve 12x equals 4x squared plus 4. So, we isolate all the terms into the right side of the equation, or we equate the quadratic equation into 0. And then, we factor it. We get the common factor of the equation, which is 4. Since 4 is divisible by 4, negative 12 is divisible by 4, and 4 is also divisible by 4. So 4x squared divided by 4 is x squared, negative 12x divided by 4 is negative 3x, then 4 divided by 4 is 1. So the common factor of all these three terms is 4. And then divide the whole equation by 4 is 1. So you will have x squared minus 3x plus 1 equals 0. So our A now is equal to 1, our B is equal to negative 3, and our C is equal to 1. Using the quadratic formula, we substitute the values. So we have negative B. So negative of negative 3 is equal to positive 3 plus or minus the square root of B squared. So you have negative 3 squared minus 4 times AC. Our A is 1, our C is 1. All over 2 times A or 1. Then simplifying further, you have 3 plus or minus the square root of 9 minus 4. Because 3 squared is 9. Negative 3 squared is 9. And then 4 times 1 is negative 4 times 1 is negative 4 all over 2. So you will have 3 plus or minus the square root of 9 minus 4 is 5 all over 2. So these are the solution of the quadratic equation. Another. Solve the following quadratic equation. 5 over 8m squared plus m minus 1/2 equals 0. So we multiply the whole equation by 8 to eliminate the numerical, the denominator here 8. So you will have 5m squared plus 8m minus 4 equals 0. So upon multiplying this original equation to 8, you will have 5m squared. Of course, we eliminate 8 already. And then 8 times m is equal to 8m. 1/2 times 8. So, 8 1/2, that is equal to 4. Equals 0. And then simplifying by factoring 5m squared plus 8m minus 4. The factors are 5m minus 2, the quantity, and then times the quantity of m plus 2 equals 0. We have learned factoring when we were in grade 8, right? Okay, so that we equate this 5m minus 2 equals 0 or m plus 2 equals 0. Then solving for m, you have m is equal to 2 over 5 here. We transpose negative 2. So that will become positive 2 already. And then divide the whole equation by 5 to eliminate the numerical coefficient of 5. So you have 2/5. Or m is equal to negative 2. By simply transposing positive 2 to the right side. So the values of m are 2/5 and negative 2. How about graphing quadratic equations into variables? We spent a lot of time graphing linear equations. In linear equations, that was when we were in grade 8. The graph of a quadratic equation is a parabola. The highest point or lowest point of the parabola is the vertex. So sample of parabola are the bridges, the parabolic bridges, the hanging bridge. All those are samples of parabola. Okay, the curve. Okay, the parabola. Axis of symmetry is the line that runs through the vertex and through the middle of the parabola. So, axis of symmetry. Symmetry meaning it divides the parabola into two congruent parts. So, it's a vertical line or a horizontal line that divides the parabola into two equal parts. Example. So, we graph y is equal to 2x squared minus 4. So, values of x and y. If x is 2, then y is equal to 4. So, using the Cartesian plane, so we plot 2, 4 there. So, here is 2, 4. And then if x is 1, then y is equal to negative 1. So, we plot there. There is 1, negative 2. If x is 0, then y equals negative 4. So we plot 0, negative 4. So there you go. Then if x is negative 1, then y is negative 2. So we plot negative 1, negative 2 there. Okay? And then if x is negative 2, then y is 4. So we plot there negative 2, 4. And then we connect the points. So you will have the parabola or the graph of the equation y equals 2x squared minus 4. As you can see here, our vertex is the lowest point, which is 0, negative 4. And our axis of symmetry is exactly the y-axis of the Cartesian plane. Okay. So how about the intercepts of the parabola? Although we can simply plot points, it is helpful to know some information about the parabola. We will be graphing prior to finding individual points. To find x-intercept of the parabola, we let y equal 0 and solve for x. The same is true with the linear equation. To solve for the x-intercept, we let y equal 0 and solve for x. To find y-intercept of the parabola, we let x equal 0 and solve for y. The same is true with the linear equation. To solve for the y-intercept, we let x equals 0 and solve for y. The characteristics of the parabola. If the quadratic equation is written in standard form, for example, we have y is equal to ax squared plus bx plus c. 1. The parabola opens up when a is greater than 0 and opens down when a is less than 0. Meaning, if here, if a is positive, then the parabola opens up. So the opening of the parabola is upward. If a is less than 0, meaning a is negative, then the parabola opens down like this. Okay. And it is impossible for a to be equal to 0 because if a is equal to 0, this is not a quadratic equation anymore, but a linear equation already. So it's impossible to have a equals 0. 2. The x-coordinate of the vertex is negative b over 2a. So if the quadratic equation is written in standard form, to get the x-coordinate of the vertex, you use the expression negative b2 over 2a. Just substitute b and a here to get the x-coordinate of the vertex. And to find the corresponding y-coordinate, you substitute the x-coordinate into the equation and evaluate for y. So the result that you are going to get this, you substitute into the equation and evaluate for y to get the y-coordinate. And then, there you go, your vertex. If you have any clarifications, any questions with regards to what we discussed today, feel free to send me a message using our group chat, Mathematics 9 Socrates. Thank you very much and happy learning. Everyone, keep safe and healthy. Thank you.